Welcome to this explainer. Today, we're equipping you with the strategic mindset and the sheer technical depth you absolutely need to ace any senior backend developer interview. Look, if you're stepping up into a senior role, interviewers aren't just looking for a code monkey anymore. They want an architect, someone who deeply understands trade-offs, knows how to scale systems, and can communicate complex ideas without breaking a sweat. So we're going to break down the exact patterns, the hidden traps, and the core concepts you need to master. Let's get into it.
Here's our playbook for today. 1. Architectural styles and trade-offs. 2. Scaling and performance optimization. 3. Bulletproofing your API security. 4. Mastering system design whiteboards. And 5. Acing the behavioral interview. All right, starting off with Section 1, Architectural Styles and Trade-offs, Making the Right Choices. When you're making these foundational architectural choices, you've got to avoid rookie traps right out of the gate, like putting verbs in your URLs. Always use nouns, like /users instead of /getUsers. Once you've got that baseline, you'll usually face your first major matchup, choosing REST versus SOAP. As a senior engineer, you need to articulate that REST uses lightweight, cacheable JSON, which is just perfect for modern web apps. But contrast that with SOAP, a strict, heavy XML protocol. And you know what? SOAP still absolutely makes sense for legacy enterprise systems that demand rigid formal contracts or robust WS security. But listen, REST isn't some magic silver bullet. You have to justify when it's time to pivot. If an interviewer asks how you'd handle high-throughput internal microservices chattering with each other, pivot to gRPC for a massive performance boost. Or what if they ask about a front-end client that needs to fetch deeply nested data without overfetching a ton of junk? That's when you suggest GraphQL. It is all about picking the exact right tool for the job.
Moving right along to Section 2. Scaling and performance optimization. Handling the load.
The whole game here is predicting latency traps way before they hit production. Take the notorious N+1 query problem. Imagine fetching 100 users and accidentally triggering 100 separate database queries just to get their posts. It's a classic mistake. You resolve this by using precise ORM methods like select_related or join load. Also, when they ask you about rate limiting, please don't suggest brittle in-memory counters. They will fail instantly the second you put them behind a load balancer. Instead, advocate for a distributed architecture using a Redis token bucket algorithm to handle those sudden traffic bursts gracefully. You really prove your competence by writing code that's ready to scale from day one. When you're discussing database optimization, make sure you explicitly mention configuring connection pooling. By explicitly defining a pool size and a max overflow buffer, you ensure your application actually reuses database connections rather than expensively tearing them down and rebuilding them for every single request. It's a total game changer for performance.
Now, what about handling massive, long-running background tasks, like generating an end-of-year financial report? Whatever you do, never block the client thread. The asynchronous request pattern is your absolute gold standard here. The client makes a request, your server instantly fires back a 202 accepted status, along with a special status URL. The client then just pulls that URL until it gets a 200 completed. It keeps your whole system responsive and the client perfectly informed.
Okay, Section 3. Bulletproofing your API security. Time to protect those resources.
Confusing fundamental security concepts is a massive red flag for any hiring manager. So here is literally the single most common interview trap that even highly experienced engineers stumble into. Do you know the exact technical difference between a 401 and a 403 status code? Take a second to really think about it.
Got it? Well, the answer is crystal clear when you put them side by side. 401 technically means unauthorized in the HTTP spec, but practically, it means unauthenticated. The server literally does not know who you are. You need to log in. Now, a 403, forbidden, that means the server knows exactly who you are logged in, but you simply lack the permission to proceed. Trying to re-authenticate is definitely not going to help you there.
Another huge test you'll face is how you store authentication tokens on the client to mitigate cross-site scripting, or XSS, and cross-site request forgery, CSRF. The senior-level strategy? You keep short-lived access tokens strictly in memory to totally neutralize XSS attacks. Then, you store your longer-lived refresh tokens safely tucked away inside HTTP-only strict cookies. And never, ever store sensitive tokens in local storage. Just don't do it. Similarly, implementing a rock-solid chorus configuration is non-negotiable. Browsers use options pre-flight requests to check if cross-origin requests are even allowed. You have to explicitly whitelist your allowed origins, and absolutely never pair a wildcard origin with credentials. That is a fast track to a catastrophic data breach for sure.
And what about webhooks? To ensure incoming webhooks actually came from the expected third-party sender, you rely on cryptographic verification. You generate a hash using your shared secret and the payload, and then, this is the crucial part, you perform a secure, constant time comparison, like a Python HMAC digest. That constant time comparison is vital to prevent timing attacks.
Let's pivot to Section 4, Mastering System Design Whiteboards, Architecting the Solutions.
When you step up to that whiteboard, you have to drive the narrative. Say you get a classic prompt, like designing a hotel booking system. Don't just immediately start writing code. Clearly map out your core REST resources and endpoints upfront. Establishing this logical foundation, like defining /hotels/bookings and /hotels/ID/rooms, shows them that you think systematically before you ever touch the implementation. Now, a guaranteed follow-up question in that booking scenario is going to be about network failures during checkout. To prevent catastrophic double bookings and ensure payment safety, you need to demonstrate item potency keys. The client sends a unique UUID, and with a lightning-fast Redis cache check for that key, your server guarantees that even if that post request gets retried a dozen times because of a bad connection, the actual transaction only happens once.
When the whiteboard moves over to scalable search, make sure you explain that standard relational databases really struggle with complex, fuzzy matching at scale. Justify offloading that complex filtering to a dedicated engine, like Elasticsearch. And if they ask how to handle user deletions, elegantly implement soft deletes by simply adding a deleted _@ timestamp column to your database, rather than permanently destroying valuable historical data.
What if they challenge you with the nightmare scenario? Migrating a massive, tangled legacy system to a new version without breaking existing mobile clients in the wild. Outline the strangler fig pattern. You deploy version 2 right alongside version 1, gradually route new features to version 2, migrate the old endpoints piece by piece, use sunset headers to warn your consumers, and finally, turn off version 1. It completely proves you understand the reality of backward compatibility.
And during those inevitable engineering debates about adding real-time features, you need to accurately contrast your options. WebSockets are incredibly powerful, offering true bidirectional communication for chat apps or multiplayer games, but they are heavy, and they require complex manual reconnection logic. Server-sent events, or SSE, beautifully simple. They use standard HTTP for server-to-client updates, perfect for basic notifications or live stock tickers, and they come complete with automatic reconnection right out of the box.
Finally, Section 5, Acing the Behavioral Interview, Communicating like a Senior.
This round is not just a culture fit test, it's where you translate deep tech to non-technical stakeholders to prove your leadership potential. If a product manager asks you to explain what an API actually is, use the classic restaurant waiter analogy. It's a fantastic, memorable soundbite. The menu is the API documentation. You give your order to the waiter, that's the API, who then goes back into the kitchen, your backend, and brings your food out to you. It brilliantly demystifies a complex constraint without using a single piece of jargon. As we wrap up this explainer, remember that acing the interview means balancing pure architecture with business reality. Consider this provocative trade-off to really prove it. True REST requires strict HADOS constraints, where the server provides all next possible actions via hyperlinks. Yet, almost no major tech company actually implements this in the real world. Discussing this showcases architectural pragmatism over academic perfection. Knowing the rules is absolutely crucial, but knowing when to bend them for the sake of the business, that is what makes you a senior engineer. Keep pushing those boundaries and you are going to crush that interview.